Hello guys, so this is the part 4 or the continuation of our series of discussions in mathematical physics related to vector calculus, where we are solving certain problems in vector calculus. Now, if you were not able to watch the previous videos, we have the part 1 to part 3. You may just watch them in our on our YouTube channel. So now we will be evaluating this one. Evaluate the integral a dotted to dr from, or ADR, from the point P1, 0, 0, 0 to P2, 1, 1, 1 along the curve r equals ti hat plus t squared j hat plus t cubed k hat with x equals t, y equals t squared, z equals t cubed, where a equals yi hat plus xz j hat plus xyz k hat. Okay, so let's do this one. So as a reference, we'll just write down or rewrite our given quantities. We have r equals ti hat plus t squared j hat plus t cubed k hat with x equals t, y equals t squared, z equals t cubed, where a equals yi hat plus xz j hat plus xyz k hat. And this is actually very straightforward. No? We actually just have to substitute or plug in these quantities to our integral. So here we can notice that since x is equal to t and y is equal to t, we can say that y is actually equal to x squared. We have y equals t squared, and since t is equal to x, so we have y is equal to x squared. And the same as well for z, since z is t cubed, so here we rewrite z to be equal to x cubed. So this means that if we're going to get the derivative of y, so this means that we have dy is equal to 2x dx, and dz is 3x squared dx. And then we just have to plug this inside our integral. So as we know, a is equal to yi hat plus xz j hat plus xyz k hat. So we just have to write it down here. We have yi hat plus xz j hat plus xyz k hat dotted to dr, which basically is just dxi hat plus dy j hat plus dz k hat. Now we have to remember here that for unit vectors, okay, we have I dotted to I hat, or I hat dotted to I hat is equal to 1, j hat dotted to j hat is equal to 1, and k hat dotted to k hat is equal to 1. Otherwise, the answer is 0. So here we can notice, or by applying these conventions, that a unit vector dotted to itself is equal to 1. Otherwise, it's equal to 0. So by applying this, we can see that only those, or after distributing this one, only those that have the same unit vectors survive. So we have here y dx, y dx. Okay, so as we know, y is x squared. So that is why we have here x squared dx. Then we have here xz times dy. No? So we have xz dy. But of course, since we know that x or z is equal to x cubed, so we have x times x cubed, that is x to the 4th. And we have dy, okay, is 2x dx. So that is why we have here 2x to the 5 dy. And finally, we're going to multiply xyz k hat by dz k hat. So of course, k hat dotted to k hat is equal to 1. So we have x times y, which is x squared, so that is x cubed, times z, which is x cubed, so that is x to the 6. And of course, since dz is equal to 3x squared, so that is why we have 3x to the 8 dz. And we have to evaluate this from 0 to 1. So after integration, we will find out that the answer is equal to 1. So if you have clarifications or suggestions, or if you have comments, you may just send me an email, or you may just write your comments in our comment section. Thank you so much.